So today we are covering chapter 6. Y'all, this is the last chapter. It's 6.1 and 6.2, and then we are done with material for the semester. You're almost there, y'all. Okay, so section 6.1 is talking about area between the curves. And I have highlighted up there graphing technology allowed. I should probably put graphing technology required because you're not going to have to do these by hand. I am going to ask you to work one definite integral by hand just to show you know the process. It'll probably have a U substitution in it. But after that, you're just going to be allowed to use your calculator. Like I'll specifically say on the test, do this integral by hand, you know, where you plug in the B and you plug in the A and you subtract them. But after that, if I don't specifically tell you to do that, we're going to use technology. So instead of technology allowed, I'm going to come change that to required. So you can use Desmos, you can use graphing calculator. Okay, so I had you think about this if you got in the room early. Normally I would put you into groups and make you try something. We don't have time to do that online. But I was asking you to brainstorm ways to find the area that's trapped between these two curves. So f of x is this quadratic function here. And g of x was this linear function right there. And then the area trapped between them is this green area that I'm highlighting. I want to find the area trapped between those curves, that green area. Like what in the world? How would I do that? And last class we talked about how integrals calculate the signed area. We're going to talk more about what that means today, signed area. But the signed area between a curve and the x-axis, that's what an integral is calculating. So I'll just pause for a minute. Did anyone brainstorm an idea that they want to share? Yeah, there you go. Cassandra, that's right on the money. She's suggesting we subtract two integrals. Why would we do that? Let's look at this. What would happen if I just found the integral of f of x, the whole integral of f of x dx, and I don't know, I could pick it, well, first of all, what do you think our limits of integration should be if I'm trying to find just that green area? And remember, you're looking on your x-axis to find those limits of integration. Like, where do you think I should start and stop? Well, they intersect right here. So I'm going to go from 2 until right there, till 7. Okay, so if I found the integral of function f between 2 and 7, this is what I would be finding. Okay, I'd be finding the area under this curve trapped between the x-axis. So I would be finding all this area right there. I shaded it in red. I'd be finding all that area. So let's write down what that is finding. This is going to calculate area under f of x, or I should say between, instead of under, between f of x and the x-axis. But do I want all of that red shaded area? No, I don't. I don't want this part right here. I don't want any of that. Okay, well, what is that area? That's the area under the line, under the g of x function, and the g of x function and the x-axis. So I can calculate that. That would just be the integral from 2 to 7 of the g of x function dx. So this is going to calculate the area between the line, so g of x, and the x-axis. So if I take all that red shaded area under the parabola and I subtract off that blue shaded area under the line, if I subtract those, that's going to calculate just the green area trapped between the curves, right? That's going to calculate the area trapped between the parabola, so between g of x and f of x. And we'll just use technology to do that. But before I do that, show me a status how you feel about the integral of f of x, finding the area under the parabola, the integral of g of x, finding the area under the line, subtracting them, leaving that green area left over. How do you feel about that idea? Show me a status. Does anyone have any questions about why subtracting those integrals will leave us just that green area? Because I promise if you have a question, at least one other person does too. Okay. Well, to calculate that, we would just totally straight up use Desmos. Like I would not have you calculate that by hand. So what I would type into Desmos is the integral from 2 to 7, and then I would put my f of x function, the way it was written for me there. And I would definitely put that in parentheses or brackets because it's two terms. So I want to make sure all that integral is there. Then the integral from 2 to 7 of the g of x function. Again, that's a binomial, so I put it in parentheses or brackets. So you have to be really careful with how you enter things into Desmos. But when we type all that in, it'll give us the area trapped between those two curves. It'll calculate that. It'll give us just this green shaded area there. I won't take the time to actually type that out right now. The important thing is setting up those integrals because technology will do that for us. Okay, so this is going to be the basic idea that we explored today in class. This idea of an integral finding the area between the curve and the x-axis, and this idea of subtracting these integrals together. And of course, there's a big theorem for that. So to find the area between two curves, we have this theorem. Okay. So to find the area between two curves, your first job I highlighted there is going to be to sketch the graph. So you'll use Desmos or a graphing calculator to sketch them because remember, I needed to see where those graphs intersected so I could find my limits of integration, right? So I definitely want to sketch that out. And you're going to sketch it on your paper because I'm not going to see your technology. So every single problem in this section is going to start with a sketch. You're going to use technology to get a graph and then you're going to sketch it for me. So if you mess up, at least I see what you saw, right? So I can give you some partial credit. So that's one of the downsides of using technology is the whole partial credit aspect. So write as much as you can on your paper to help me give you points if you mess up. So you would want to sketch this graph. You would want to show where they intersect. Then you'll set up your integrals. Then you'll just get your answer with technology. Okay, so I'll walk you through what all that's going to look like, but I highlighted it there. So your first step will be to sketch a graph. Just sketch it on the paper to figure out those points, you know, which graph is on top, like which curve is above the other one. Got to figure all that out. Where do they intersect? Got to find all that stuff out. And then you just set up your integrals, and you can write them as two separate integrals. Since we have technology, that's what I usually do. Or you could write them as one big integral if you wanted to. Just remember, order is really important when you subtract. So make sure, however you do it, you're putting the top curve first and the bottom curve second. If not, it'll flip-flop the sign of your area. Okay, so what in the world would this look like? Let's see what a problem on your homework is going to look like. Okay, so this is what you're going to see. Find the area bounded by the curves f of x, it's a parabola, and g of x, that's linear. And they're telling me where to look between, right? Between x being -2 and x being +2. Okay, so I have my limits of integration. I have my a and my b there. I just have to get an idea of what this looks like. So I'm going to go to Desmos to sketch this out. And some of y'all might know what this looks like. You might know that this is a parabola opening down, intersecting at 1. So it's up at 1, it's going to open down. And then you might know that that's a line, it's going to intersect, it's linear, it's going up, it's going to intersect at 5. 1, 2, 3, 4, 5. No, so if you're, I sketched that too. So it's positive slope of 1. So this is your slope, this is your y-intercept. So like you might be able to sketch this by hand, but I'm just going to use technology to make sure sure that we got all that nice. Let me, sorry, I'm going to just move this down since I didn't think that through when I was drawing. Okay, so I'm claiming, this is my graph, let's double check it. And this was my g of x line, and this one was my f of x parabola. Okay, let me go see if that is right. So let's go over to Desmos. Sketch that in. Okay, lots of switching over to Desmos today. Maybe I can just share my entire screen the whole time. I'm going to try that so I don't have to go back and forth. Why didn't I think of that earlier? Okay, so let's go to Desmos. Clear that sucker out of there. So f of x was 1 minus x squared. G of x was x plus 5. Yep, so I sketched it correctly. So you would sketch this down on your paper. And then we're wanting to go look between -2 and +2. I'm going to add this to my graph. You don't need to, but x equals -2 and x equals +2. I just got some sketches there. Let me see if I can make that purple. Let's make orange is easier to see. Okay, so I'm wanting to find the area under this line, between this line and this curve. So the top one is my linear function, the bottom one is quadratic, and I'm pretend that all this area between -2 and +2 is shaded in. So I'm going to go draw that on my graph, on my paper, and then we'll just enter that in. Well, let me enter the integral while we're here, right? And then I'll go translate that to my graph. So what is my integral? I'm going to do my integral, so functions miscellaneous integral. And since I've typed it in this way, for my technology, I can do a couple of things here. My limits of integration are set. Okay, but then I can just straight up type what function was on top? The g of x? G of x function minus, and then f was on bottom, f of x function, dx. Look at that. I can just type it in like that. Or I could type the rules in if I wanted to. But if you're typing the rules in, you have to be really, really careful. So let me show you what that would look like. Since I already had it graphed, I had g defined and f already defined, but I could also type it like this. Okay, so the g of x function, I'm going to put in parentheses, was x plus 5, minus the f of x function was 1 minus x squared d of x. I get the same answer either way. This is just my linear function. It's a binomial, so I put it in parentheses. This is my quadratic function. It was a binomial. I put it in parentheses. Top curve minus bottom curve. I put the whole integrand in parentheses in either case. So how are you feeling about that idea so far? This idea of using technology to get a picture in your, so you know how to set up your integral. Show me a status. Now, next class, we're going to do all the word problems that relate to this idea. But right now, let's just go put this on the paper, on our paper, and see what this is going to look like. What do I want to see when I'm grading your work, right? So let's pull this up here. Yay, that we'll just go back and forth. Okay, so this is what I would write on my paper. So I would go from -2, I don't really remember what that looks like. Hold on. Where did it? So it intersected below the x-axis. Okay, so -2 is like over here somewhere. You know, this is just a sketch. Don't spend a lot of time making it gorgeous, but this was -2, and then +2 was still below the x-axis. Okay, and then +2 is like, I don't know. Ah! So it's this area. And then I'll set up my integral. So it's the integral from -2 to 2. And I can just write it out, g of x minus f of x if I want. I don't have to write all the rules. dx, and then I can put the answer. It was 21.3. That's all I'd have to see on your paper. The graph, the shaded area, the integral, and the answer. It's not a word problem, so there's no units or anything. Okay. Well, let's try another one. What about this one? It says find the area bounded by those two curves. There's a parabola again and a linear function. This parabola is a little bit harder to sketch, so I'll definitely use Desmos for that. So I'm going to hop over to Desmos and graph those. So x squared minus 4x. Okay, so let's see what those look like. So let's break all this up here. Okay, so f of x was x squared minus 4x, and g of x is just the identity function. Okay, so this is what it looks like. Oops. And I'm going to go over here to settings, and I'm going to count by ones on both my x and y axis, and I'm going to remove those minor grid lines just to help me read a little bit more. Okay, so here is our graph. So I'm going to sketch it on my paper, and luckily here I can see exactly where the points of intersection are because I'm wanting to find this area trapped between the curves, right? So I can see it crosses at 0, 0, and I can see it crosses at 5, 5. But if you didn't see that, Desmos is awesome. You just click either one of these graphs. So I'm going to click the blue one, and it'll automatically calculate those points of intersection. So you just hover your mouse over those points. So 5, 5. So because it could have been 5.1 or something if I was trying to eyeball it. But if I click on, I can also click on the green one. If I click on the green one, it'll automatically calculate those intersection points. You just hover your mouse over it. So it is from x going to 0, x going to 1. So just all that shaded area trapped between those curves. So let's go sketch that. Oh, before I sketch it, while I'm here, let's actually find our integral. So what would that look like? I'll be quiet for a minute and let you set it up. Okay, so hopefully you set it up from 0 to 5, and then the linear function is on top. That's the g of x function. Minus the quadratic function is on bottom, so that's our f of x function. I put it all in parentheses, and then I put my bookend. So I got 20.833333 repeating. How are you feeling about that? Show me a status. Feeling okay with using technology to sketch each of the functions and then to use the picture you get to set up an integral? We feeling okay? Well, let's go set this up on our paper. What would I need to see? Okay, so let's, and again, it's just going to be a sketch, so I'm not expecting like beautiful perfection here. So I would just sketch it out like this. Oh man. Well, I know g of x was like this, and then f of x, they're going to cross at 0, 0. So I don't know, kind of look like this one. But I'll put here, to be super blatant to the grader, I'll put where those are intersecting. And then we were wanting this shaded region. And the g of x function is on top, and the f of x function is on bottom. Okay, that looks like a good enough sketch. I'd give you points for that, even though it's hurting my brain a little bit. And then you just have to set up your integral. You're just going to go from 0 to 5. Then we had the g of x on top minus the f of x on bottom. And then the answer was 20.83 repeating. Be really careful on my math app how they want you to round that. I'm just going to write it as 20.83 repeating, but it's not too bad. Of course, we're going to put this into word problems after Thanksgiving, but right now we're just getting the technology under our belts. Any questions before we move on to the next idea? Okay, let's move on. Okay, so the next idea is we're going to revisit one of the vocabulary words in the definition we looked at last week that I kind of just skimmed over. I didn't want to overwhelm you with details last week. I wanted you to get used to the technology. I wanted you to get used to the notation. Now we're going to get into a little bit more of the nitty gritty here, okay? So the word I skimmed over was this idea, the signed areas. When you calculate this definite integral, you're actually calculating a signed area between the graph and the x-axis. Signed area. Okay, so let's explore this idea a little bit. So I've given us a function. It's quadratic. I sketched it here. It's this parabola. That's f of x. I should label that. This is f of x. Okay. And I want us to type just this into the calculator. I want us to type, or into Desmos. Let's type this in here. But before I do that, let's shade it on the graph from 0 to 2. So here's x equals 0. Here's x equals 2. And remember, it's between the graph and the x-axis. The graph and the x-axis. So that would, here's my x-axis. Here's the graph. So it's just this area here. And we're going to type it into our calculator and see what we get. So I'm going to go type it into Desmos. X squared minus 4. Okay, so the integral from 0 to 2 of x squared minus 4. And it's telling me negative 5.3333333333. Negative 5.3333. Now, normally in math, areas aren't negative because normally we think of area as like length times width, and lengths can't be negatives and widths can't be negatives, right? But here it is. This is negative. It came out to be negative 5.333. Well, what is happening? Let's think about that. I'm going to set up this integral. F of x dx from 0 to 2. So if I was going to break this up into rectangles, let's break it up into 2 rectangles, right? Here's 1, here's 2. Let's make them left rectangles. So if I was going to break these up into left rectangles, remember breaking them up into rectangles? So I chose 2 left rectangles. When I go to, remember, when you go to calculate your f of x, that's the height of the function. F of x is always the height of the graph. And d of x, the change in x, is like the width. Right? So your width, your d of x, is going to be positive, but what's happening with that f of x? The height of the graph is going to be negative, right? So f of 0 is down here at negative 4, and f of 1 is down here at negative 3. So we're technically calculating negative areas there. So anytime your graph is below the x-axis, we'd be calculating a negative area. So why is the answer negative? Because the graph is below the x-axis. Okay, but then if we switch gears over here, if I look now between 2 and 3, so if I pick back up at 2 and I go to 3 and I look at the graph and the x-axis, see how that is above the x-axis now? So I'd expect this answer to come out to be positive because it's above the x-axis. And we can verify that on Desmos, right? Because if I went to draw a rectangle for this one, I'll use a right rectangle this time. If I went to draw a rectangle for that one, the d of x is still positive, but also my f of x is going to be positive. F of 3 as a positive number. So I'd expect it to be positive because we're above the x-axis. Let me go to Desmos and calculate that, what that is, from 3 to 2. Okay. I'd expect it to be a small, like less than 5 because it's less green shaded area there, but here we go. Okay, so we're just going to go from 2, oops, 2 to 3. Oh, there we go, 2.3333. It's positive. It's positive area. Okay, so let's go write that 2.3333. Okay. 2.33333. Okay, now here's the deal. This is this big idea we're working up to here. If you wanted to go from 0 to 3, okay, so I wanted to go, let's get it from 0, x equals 0, all the way to x equals 3. And part of that area was below the x-axis, and part of that area is above the x-axis. So part of it was negative 5.33, and part of it was positive 2.33. What would you think if I added those together? What happens? What happens when you add a positive to a negative? They cancel out, right? They like vaporize each other. So if I had more negative space than positive space, when I add them together, I'd predict that overall I'd end up with a negative area, right? Because I had more negative space, more negative area than and less positive area. So we can just check that on our calculator. Let's plug it in from 0 to 3 and confirm we're going to end up with a negative number there. So 0 to 3. So now I'm going to go from 0 to 3. Yeah, I ended up with negative 3. Now here's the deal. When we're adding these areas together, sometimes we don't want to add the signed areas because if there's space below the x-axis that has a negative area and space above the x-axis that has a positive, when we add them together, they'll cancel each other out and we won't get the total area. Like if I was wanting to buy paint for this, you know, I'm just making up a silly example. I wouldn't buy enough paint, right? Because even though I'm painting below the x-axis and I'm painting above the x-axis, if I just did a calculation real quick, I'd be like, oh, I need 3 gallons, you know, or something. I don't know. And I wouldn't have enough. That's a bad example. But anyway, sometimes we don't want the areas to cancel out. We want to just add the absolute values of the areas, basically. So I want to think about this area under the x-axis is just an absolute value of positive 5.33. So when I add it to the area above the x-axis, they don't cancel out. And we can force that to happen a lot of different ways. And we're going to talk about the different ways to force that to happen. Okay. And I have that here in number 6. It says, in chapter 6, we want to use definite integrals to find the actual area between the x-axis and the curve, not the signed areas, because they'll cancel out when we add them all up. So if you want to find the total area trapped between the x-axis and that graph, then there's 2 ways to think about it. One, we're going to think about the x-axis as its own function. So I'm going to resketch this. This is the textbook way to think about it, and then we're going to think about it another way. So I'm going to resketch this graph. Oh man, I should have typed it twice. I don't know why I didn't think about this. So it intersects at -4 and at 2. Okay. Okay, so it looks like this is my okay, so if I wanted to find the integral from 0 to 3 of that function, and I want to find the total area, we're going to think about the x-axis being its own function, which it is. What's the function of a horizontal line with a y-intercept of 0? That would just be g of x equals 0. Right? This is just y equals mx plus b. with a slope of 0 and a y-intercept of 0. So y is just 0, right? So just basic algebra happening here. And then we're going to have our function. So here's our function, f of x. And we're wanting to go from 0 to 3. So let's mark that on our graph. So 0 is right here. And 3 is over here. So part of that time, my area is going to be below the x-axis between 0 and 2. And then part of the time, it's going to be above the x-axis from 0 to 3. So see how the x-axis and the function are like flip-flopping? They're changing places. So I just have to set up two different integrals. I need to set up an integral where the x-axis is above the parabola, and then I need to set up another one where the parabola is above the x-axis. So one time I'm going to have g of x on top and f of x on bottom. And then it's going to flip, and then I'm going to have f of x on top and g of x on bottom. So basically, we're just splitting the big integral up into two separate ones. Okay, so let's set up those integrals. So my first integral from 0 to 2 has g of x on top and f of x on bottom. So remember, g of x was just 0, and f of x was a binomial. It was x squared minus 4. So I have to put that binomial in parentheses. So all of that is my first integral. Let me shrink this down for a sec. Okay. And I just put, oops. G of x was on top, f of x was on bottom. Okay, and then I'm wanting to add, I want to add the next part, right? Because I want the total area. So I'm going to add the integral from 2 to 3, but this time f of x is on top and g of x is on bottom. So f of x was the x squared minus 4, and g of x was just minus 0. And you can put f of x in parentheses if you want. You don't really need to since it's at the beginning. There's nothing to distribute. But if I just type all that in my calculator, it's going to force those areas to be positive. So I'm going to go do that. I'm going to type that into Desmos. And then it should be, remember, this area, we already knew that this area was going to be negative 5.33. And we knew that this area was positive 2.33. So it's basically what this integral is doing is it's forcing that to come out to be a positive 5.33. And this one's already going to be a positive 2.33. So when you add them together, you're going to get a yucky number, y'all. And I did that on purpose because my math lab just gives you random numbers and they're pretty yucky. So you're going to have to be really careful with rounding and stuff. So let's see what Desmos tells me happens here. So let me go type this into Desmos. Okay. So what I'm going to do here is I'm going to define f of x to be my x squared. Oops. I have my cap lock on. F of x is going to be x squared minus 4. Okay. And g of x is going to be 0. So my x-axis, let me do it a different color to agree. Okay. So I have my parabola and my x-axis. Okay. And then I'm going to set up my integral. One time I'm going to do from 0 to 2, g of x, the green one is on top, and the parabola is on bottom. And if I stop right there, see how it forced my negative 5.333 to be positive 5.333? Okay. And then I'm going to add the integral from 2 to 3. And this time, the f of x function is on top, and the g of x function is on the bottom. So I add them together. I got 7.666666666 repeating. I don't know. How are you feeling about that? Do y'all have any questions? Am I going too fast? It's so hard to tell online if I'm going too fast. If at any time you need me to slow down, just let me know. So how do you feel with this idea of using the picture to help you set up two integrals? One integral for when the x-axis is on top and one integral for when the x-axis is on bottom. 7.6, let me go write that down. So 7.67 if I round it. So be really careful with rounding. So you just set up two integrals. So I should say, I'm just splitting this guy up to two integrals. And they flip positions there. Okay. Embrace the technology, y'all. This is the stuff. You know what this is? Y'all, you should totally leave these notes out on your coffee table when people come over for Thanksgiving with their masks on, socially distanced. This is the stuff you want people to see, right? Doesn't that look like super cool and intimidating? People are gonna be like, whoa, what are you doing in that business calculus class?
You know, in those movies that are like, you always see somebody like on the board, like writing these like crazy things, but that's what that looks like.
Seriously, that could be you. Buy a whiteboard and write this all over. And when people come over for Thanksgiving, they're going to be like, damn, what are you up to? Seriously, guys, I'm doing you a favor. It's a good conversational, like a conversation starter. Or maybe not. Okay, here we go. So let's take a look at some of these. What is this going to look like? Okay. I'm not even going to show the other way to do it. I'm just going to just do the MyMathLab way because that's what the help tools are going to say. So the MyMathLab way is always make the x-axis a function of 0 output, right? Because the height is always 0. So we're just going to stick to that. Okay, so what is this problem asking us? It's asking us to find the area between the graph of f. So they gave us a parabola again. This parabola. I should label that f. I don't know why I'm being so lazy on my notes. Okay. And the x-axis. So we're going to go between that and the x-axis. The x-axis is just g. I'm going to label that g of x there. Equals 0. Okay, and then we're looking over two different intervals. So the first interval they want us to look over is from 1 to 2, and then we're going to repeat the whole process for number 6 between -1 and +1. So let's look from +1 to 2. So +1 to 2. Ooh, so from +1 to 2, it's just under the x-axis the whole time. Okay, so if you made the mistake of writing this from 1 to 2 of f of x, let me just put f of x. Let me go ahead and type that into Desmos and just show you what's going to happen here. So from 1 to 2 of x squared minus 2x. Like when you get really good at calculus, this will be what you do here. So f of x was x squared minus 2x. Okay. And then if I just wanted the integral from 1 to 2 of f of x dx. See how it's giving me a negative number because that area between 1 and 2 is all under the x-axis? So When you get really comfortable and good with calculus, you just be like, oh, pff, I just need to make that positive. I just type it into Desmos and be like, oh yeah, it's negative, it's under the x-axis. I just need to force it to be positive. So if you do that on your notes, it's okay to do that and just say, write a note, force this to be positive. But the calculus, the idea of like a curve on top and a curve on bottom will do that for you. So you don't have to have that logic. So let me show you that the calculus will force this to be positive. So if you just do this, you're going to end up with negative 0.666666, repeating. So approximate. So then you would just have to force this to be positive. So it's kind of like you're doing absolute value, right? Force this to be positive. But if you just stick to curve on top minus curve on bottom, it'll automatically do that for you. So let's break it up this way from what's really happening from 1 to 2. Well, g of x is on top minus f of x is on bottom. Right? So g of x was just the x-axis 0 minus f of x was your quadratic function, and then all of that dx. If I type that into Desmos, it's automatically going to force it to be positive, and I don't have to use any logic or think about it. So I'm going to type that into Desmos and just show we get the positive out. Okay, 0 minus x. So let me just add in g of x being 0 here. And now function from 1 to 2, where g of x is on top and f of x is on bottom. Boom. Just forces the answer to be positive. No interpretation needed. I don't care which way you do it. If some of y'all have had calculus before, so you'll be more comfortable knowing, oh God, that was under the x-axis. I better make it positive. Others, if you're learning this for the first time, just always do top curve minus bottom curve. X-axis minus parabola in this case. And we're going to keep working with this graph, but we're going to change our limits of integration. So before we do that, are there any questions on this one? No? Okay, so let's see what happens when I change those limits of integration. So now it's the same graph f of x, which I realize now I'm learning how to teach this online, and now I realize I need to retype everything. So remember f of x was x squared minus wait, was it x squared? See, I don't even remember. It was literally 5 seconds ago. Okay, x squared minus 2x, and then g of x. G of x is just 0. And now we're wanting to go from negative 1 to positive 1. So part of my area is above the x-axis, and part of my area is below the x-axis. And they intersect, let's see, when does it change? They change at 0. So I'm just going to set up two different integrals. An integral for the area above the x-axis, an integral for the area below the x-axis. So let's see what that looks like. So my first integral, f of x is on top. Oops, that's messy. F of x is on top, right there. And g of x is on the bottom. So I'd set up an integral from negative 1 to 0 with f of x on top. So that's x squared minus 2x minus g of x on bottom. G of x is just 0. And that's going to come out to be positive anyway, because if you subtract 0 for something, does it really change? Oops. No, right? So this is what the calculus says to do. Then I'm going to add the integral, start at 0 and go to 1. And this time, g of x is on top. and f of x is on bottom. So I'm going to do g of x on top, that's 0, minus f of x on bottom, and that is a binomial parabola, so put it in parentheses. Okay. And I type all that into my calculator, or into Desmos. So I'd have to see this written out for you to get full credit, and then just whatever it equals on Desmos. So I don't know, let's go type that in, see what that equals. Okay, f of x, g of x. Oh, I already have those entered. Oh, yay. Okay. I already have the f of x and g of x entered. So I just need to do the integral from -1 to 0, where f of x is on top. Oh, I forgot my parenthesis. And g of x is on bottom, plus the integral from 0 to 1, where g of x was on the top minus f of x was on the bottom. Ooh, 2? That's a very pretty number. Did anyone else get 2 when they typed it in? Yes? Okay. Just normally the numbers won't be that pretty. Okay. Just making sure I didn't make a typo. On my math lab, you're going to get some ugly numbers, and it does not mean you're wrong. Okay, so let me go write that in. So that was just, all that was 2. Okay. I ain't scared. You got this. It's really not that bad once you get used to the technology aspect. Oops. Well, I'm just going to shrink that up a little bit. Okay. Here we go. Got another one. Is this our last problem? Wait, let me see. Surely not. Wow, y'all, one more problem. There are no word problems in this homework. Isn't that exciting? All the word problems are next week, though, so brace yourself. Wait a second. Is it possible we are going to stay on the calendar? Give me 1 second. Y'all, we are keeping our review day. This is a miracle. Boom. That's exciting stuff. Because next week is 6.2, that's the word problems, a review day, and then we split the test over 2 parts. What? Oh, God, I have to write that. Okay, cool. Sorry, I got excited for a second. Let's focus. Okay, what in the world would we do here? Find the area bounded by these curves over this domain interval. Okay, so I'm going to be quiet for a minute since we have so much time. I'm going to be quiet for 3 minutes, 3 minutes, and see what you get on this, okay? And then if you mess up, you'll know what questions to ask. So I'm going to mute myself for just a few minutes here. Okay, so what is your first step in any of these problems? You gotta sketch a graph. So I'm gonna go to Desmos and see what in the world this looks like. I know it's a parabola, f of x is a parabola, I know g of x is a line, but I don't know what that looks like. So I'm gonna go to Desmos. Here we go, and then type in my f of x, my g of x. Okay, so f of x was x squared minus x. G of x was, y'all, my memory these days, it was 2x. Okay. So what in the world does this look like? Oops. Oh my gosh. Okay. Oh my gosh. Okay. And what we're wanting to go between seriously? -1 and 3. So I need to zoom out a little bit here. Ooh. Okay, let me, oh my gosh. Sorry, touchscreen issues. Okay, here we go. Is it going to stay put? Yes. Okay. So let's go between x being -1. I'm just doing this to get a visual. And x equals 3. You know what? I should do those dashed lines since they're not really part of the graph. Okay. So, ooh, let's take a look at what's happening here. So between -1 and 0, the parabola is above the line. So function f is above function g. But then after that, from 0 to 3, the line is above the parabola. So I need to go sketch all of that on my graph. And it doesn't have to be like gorgeous, so I'm not going to get too persnickety. And where did those intersect? I don't really care about the height, but okay, here we go. Well, let me sketch it out. So, dun, 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 dun. So I know my g of x is a line. And f of x, they intersected here. Oh my gosh. They intersected here. It dipped below for a second and then went up. Okay, dipped below for a second, then went up. Ah. This was f of x. Oh my gosh, I need to highlight those. Okay, so f of x will be the red one. And g of x will be the orange one. Okay, we were going from -1. So from here to 3, which was here. Oh my gosh. Okay, so you would sketch something that looked like that. Half your points right there. And then I'm going to have to write two different integrals. So for my first integral from -1 to 0, the f function is on top and the g function is on bottom. So I'm going to do f minus g. F minus g. Plus, I need to flip-flop that. An integral, I pick it back up at 0, and then I go all the way to 3, and in that case, the g function is on top, and the f function is on bottom. So g function is on top, f function is on bottom. Oh my gosh, I just have to type all that into Desmos. But to get your points, let's talk about what you need to do to get your points. So to get your points, you need to sketch the graph. So that's what you're going to do first. Sketch graph. And then show me that shaded area. What are you even trying to calculate? So we were trying to calculate this area here and this area here. The green area. So first, you're going to set up, sketch your graph. Second, you're going to set up the integral. In this case, integrals. And then third, you're just going to use Desmos, or use technology. To calculate. Okay, so let me type that into technology and see what we get here. So f on top of g, then g on top of f. Okay, here we go. Oops. I can just see that from my graph. So my first integral is going to go from -1 to 0. And in that one, the parabola f was on top of the linear g. Okay, then I'm going to add another integral from 0 all the way to 3. And in this one, the linear g, oops, was on top of the quadratic f. And when you add them all together, you get 6.3. Hey, yeah, guys, congratulations, James, Belinda, and Cassandra. What? 6.3333? Approximately. I don't know. I should have read how my math, it probably wants you to round to the nearest 10th, I'm guessing. Okay, show me a status on how you feel about this one. Are there any questions? Did anyone do anything wrong that they want to talk through? No? Okay, we are actually going to finish early today, like mind blown. Oh, I noticed during the break that I did not update the calendar. There is a take-home quiz on this stuff with the technology, so I can give you feedback on what you're entering. So when I was looking at the calendar, I realized like I didn't put what the homework was over here. So when I upload the video, and the answer key, I'll upload, there's a My Math Lab homework assignment, and then there's a take-home quiz over just what we did today. It's over 6.1, so using technology, but where you like sketch the graph, you set up the integral, use technology. I want y'all to practice that on a take-home quiz. And then y'all, no class on Thursday and no office hours on Wednesday. That's up. And then, yeah, next week we finish up Chapter 6, we review, and then you have your test in 2 parts, and then you are done. What? Oh man, y'all, the end is near. Okay, well, you are good to log out. Oh, there was a question. Go ahead.
On the calendar, it says the homework for 5.4 and 5 is
Oh,
due Thursday. You put 11:25. So is it Thursday or tomorrow
oh,
that it's due?
I meant to put Thursday the 26th. Yeah, I was just giving y'all longer because that one problem we didn't finish. Thank you, Tasha. I'm going to check that on my math lab and make it. You can always work after the due date with no penalty, but I'll change this. I was thinking the 26th, even though we don't have class. So thank you.
Okay.
So check, let me put that on my to do list. Check due date on my lab math. Okay, and then I think I heard another. Will you be telling us what chapters are on the 2 parts? Yes. So just so you know, um, oops, when we get down here to part 1 and part 2, I'm going to tell you exactly which sections to study. Basically, it's chapter 5 versus chapter 6 is usually how I set it up. I'm not sure if that's exactly how I'm going to do it this time, but I will tell you what sections to study for part 1, and I'll tell you what sections to study for part 2, because this is your last test and there's no retest option, right? So I'm trying to make this as user friendly as possible for everyone. Um, I'm also, during the review day, I need to talk a little bit about camera setup and things like that. There was an incident in a different class. So we're gonna have to, especially since we're using Desmos, I have to be able to see your screen. And this is a really large class. So we'll talk about that on review day, but there's going to be some differences about how we set up our camera. Because I have to make sure you're not going to any other websites besides Desmos, et cetera, et cetera. Oh, maybe we should do a lockdown browser. I don't know. Sorry, I just thought about that out loud. Let me put that on my to-do list. Explore. We still do it in class. It wouldn't be online, but we might use just a lockdown browser. That might help solve that. So explore lockdown option for test 4. Oh, y'all, also, I totally forgot. We're supposed to do evaluations. I'll send out an announcement. Why do I keep forgetting this? You know how the like pink envelopes We're supposed to do, when we're face to face, you're supposed to evaluate me. I'm almost terrified. I shouldn't even tell y'all, but no, I'm just kidding. You're supposed to, oh, our surveys aren't open yet? I thought it said they were open. Oh, maybe they're waiting till after Thanksgiving.